Ever wondered why Mars is often referred to as the red planet? What gives it that unique rust-colored appearance that distinguishes it from other celestial bodies in our solar system? The mystery of the red planet is a captivating one, wrapped up in the swirling dust and rock that make up its alien landscape. The key to solving this enigma lies in the very composition of Mars itself. Just as we have an array of colors painting our world, from the azure blues of our oceans to the lush green of our forests, Mars too boasts its own distinctive hue. But unlike our variegated Earth, Mars is uniformly brushed with a single defining color, red. The reason behind this intriguing coloration is written into the fabric of the planet, tied to the elements that compose its soil and rocks. The secret to Mars's red color is closer to home than you might think. It involves a compound you're probably familiar with: iron oxide. Iron oxide, or as we commonly know it, rust, is the primary reason behind Mars's red hue. Let's dive deeper into why this is. Mars is a world teeming with iron. It's found in abundance within the Martian soil and rocks. Now, when this iron comes in contact with oxygen, whether it's from a trace amount of water vapor or oxygen molecules trapped within the soil's minerals, it reacts and forms iron oxide. This is where our red planet gets its rust from. Imagine the Martian surface as a vast, sprawling canvas of fine dust particles. These particles are like tiny artists, each one rich in iron oxide. When sunlight falls on Mars, these particles go to work. They scatter the sunlight, reflecting more of the red and less of the blue part of the spectrum. This gives Mars its distinctive reddish hue. However, we can't forget about the Martian atmosphere. Although thinner than our own, it still plays a role in Mars's coloration. During a dust storm, which can sometimes envelop the entire planet, the atmosphere becomes saturated with dust particles. This enhances the red effect, further contributing to Mars's characteristic color. But it's important to remember that this is not a localized phenomenon. The iron oxide is not confined to a specific region or valley. It's a global presence, distributed across the Martian surface in an almost egalitarian fashion. This means the red color is not a feature exclusive to one area. It's a global characteristic of Mars. In essence, Mars is red because it's essentially covered in rust. It's a planet-wide phenomenon, a result of the interaction between iron in the Martian soil and rocks, and the minimal amounts of oxygen and water available. It's a testament to the unique geological history of the red planet, painting a vivid portrait visible even from Earth. But the story doesn't end with iron oxide. There are additional factors that contribute to the red planet's color. One of the key players in this cosmic drama is the weathering processes on Mars. Unlike our home planet, where iron oxide forms with the help of plenty of water, Mars takes a drier approach. The iron oxide here may form with the aid of morning frost or even ancient water sources that have long since evaporated. These processes have been at work for billions of years, allowing the iron oxide to accumulate and dominate the Martian landscape. Interesting, isn't it? How the passage of unimaginable spans of time and the persistent work of the elements can paint an entire planet red. It's a testament to the power of natural processes and the enduring mystery of our universe. But let's not forget the spread of this iron oxide. It's not just concentrated in one area like a rusty old car in a forgotten corner of the universe. No, this iron oxide is a world traveler. It's distributed across the Martian surface, making the red color a global characteristic of the planet. So if you were to stand on Mars and look around, you'd see a sea of red in every direction. From the highest peak of Olympus Mons, the tallest volcano in our solar system, to the depths of Valles Marineris, a canyon system that makes our Grand Canyon look like a small scratch, the red of iron oxide is ever present. This global distribution further enhances the red appearance of Mars. It ensures that no matter where the sunlight hits, it's always reflecting off the iron oxide-rich dust, reinforcing the red color we associate with Mars. So not only is Mars covered in rust, but this rust has been weathered and distributed across the planet over billions of years. This simple fact adds yet another layer to the intriguing story of the red planet. A story that continues to captivate us as we strive to unravel the mysteries of our universe. The presence of iron oxide on Mars isn't just a color story. It holds significant scientific implications. It's like a planetary detective story, with each rust-red clue leading us closer to understanding the past and potential future of this fascinating celestial neighbor. Let's start with the most tantalizing clue: water. You see, iron oxide or rust usually forms in the presence of water. On Earth, iron will rust when exposed to air and water, but Mars is a bit different. It's drier than the driest desert on Earth, and its atmosphere is mostly carbon dioxide. So, the abundant iron oxide suggests that there was once water on Mars, possibly in the form of morning frost or ancient, now evaporated water sources. This is a significant discovery because where there's water, there's the potential for life. Then there's the oxidation process. The presence of iron oxide indicates that oxidation has occurred on Mars. This is the process where a substance loses electrons, usually to oxygen. This reaction suggests that there was enough free oxygen at some point on Mars to react with the iron. This oxygen could have come from water molecules or from oxygen trapped in soil minerals. Understanding these oxidative processes gives scientists vital insights into the planet's atmospheric history. Finally, the formation and distribution of iron oxide can reveal a lot about Mars's geological evolution. The fact that iron oxide is not just localized but spread across the planet's surface suggests a global event or process. This could be anything from volcanic activity to weathering processes that have been happening for billions of years. So the next time you hear Mars referred to as the red planet, remember that this color tells a story of iron oxidation and a planet's evolution over billions of years.